Alright, this is your warm-up today, guys. There's 3 problems, obviously. The first 2 are you're going to need your unit circle for. The last one is not on the unit circle, the value is not. So you will need to draw a graph for that and find the values. Please give them about 2 to 3 minutes to actually fill out this warm-up. Push pause while they are doing this. Thank you. Alright guys, let's kind of get our unit circle out over here so you can kind of remember what's going on. Okay? First off, on number 1, this is not an inverse, okay? This is a regular function. That means I can go all the way around the circle, okay? Which means this is a very easy problem because I just go to 5 pi over 6. Sine is the y value, so I come over here to y and I write down 1/2. It's that easy. Inverse function, though, is those functions where our graph has been cut in half. Okay, the inverse of sine is in the first and fourth quadrants, right? This is a negative value, so it has to be in the fourth quadrant. So I'm going to come down here and I'm going to find negative 1/2, which is right here. Okay, and again, I see 11 pi over 6, but that's not my answer because 11 pi over 6 makes me go all the way around to get to it. I have to only be able to go straight down there. So that means it is negative pi over 6, just like that. Okay. Number 3. Well, the first thing you should notice is that the value that this inverse gives you is not on the unit circle, and I told you guys that. Okay. Next thing you need to notice is that this is a positive value. So that means I'm in the first quadrant, just like this. Cosine is adjacent over hypotenuse, so it looks like that. This is a 3, 4, 5 triangle, if you did not notice. So that's 8. Okay, now remember, this problem right here actually finds theta right there. Okay, so that's theta. And all I have to do is bring down my sine and solve. So what is sine of theta? And sine would be 8 over 10 or 4 over 5. And there's your answer. Alright. Let's just quickly do a little review on which quadrants all of our inverses are in. Now, first quadrant, I know that all of my inverses are there. So cosine, right? Sine, and tangent. All 3 of the ones that we've gone over. Cosine is the x value, so I know x runs left and right. Okay? So that means cosine is in the first and second quadrants. Sine is the y value, and it runs up and down, so it's down here. And tangent is y over x, and we always look at the numerator. So that's up and down as well, so that's going to be tangent is in the fourth quadrant, just like that. Okay. Today we're going to be doing all of the reciprocals. Alright, so it's going to be a continuation of those tangent notes. If you can kind of tell, tangent is at the top of this page. Okay. And same kind of thing is going to be happening. Alright, Mr. Terrell is learning how to edit. Okay. Sorry, my son walked in and I had to started messing with me. So anyways, same kind of thing is going to happen. Secant of pi over 3. Okay, now this is a regular function, so I'm looking for a value. Okay, secant is the flip of cosine, right? So I'm looking for cosine at pi over 3, and then I'm just going to flip the value over. So cosine at pi over 3 is 1/2, right? So secant at pi over 3 is 2. Okay, really simple. The inverse of secant. Now, remember, all inverses have those restrictions to it, so we have to actually account for that. What's nice about this is that the reciprocals of secant and cosecant will actually follow their corresponding reciprocals, so cosine and sine. So secant and cosine actually are in the same two quadrants, because this is 1 over x. Okay? So whenever I look for this, I know that secant is going to be in the first and second quadrant. This is a positive value, so I'm in the first quadrant, right? So my answer is pi over 3, which makes sense because all we did was the exact reverse operation. We kind of got back to where we started, right? Okay, so what does that mean? What did I just say? What does that actually mean to us? All right, we'll just kind of take a look. Reciprocal of cosine is secant. Okay? Secant's just the flip of x, so x runs left and right. So secant, the inverse of secant, is actually in the second quadrant as well. Just like that. Okay? Sine, we have cosecant, right? Is the reciprocal. So that's just like saying 1 over y. So that's still the y value. Okay, so that's up and down. So cosecant goes here. Okay, and notice that all 6 functions are actually in the first quadrant. So we have to know that. Now cotangent is the tricky one, because cotangent also has a y and an x, right? This was tangent, if you remember, and cotangent is just the flip of this, so that would be x over y. Now if you look at the numerator now, it's the x value, so that means that cotangent actually runs left and right, so it's over here. So kind of out of room, but it's right there. Okay, now this is all 6, and this is where they all go. And if you notice, there's nothing in the third quadrant. So if you give me a value or an angle kind of thing down here, when we're using inverses, I know you have no idea what you're doing. Okay? Remember, inverses gives you angles. So I should not see a single angle down here in any of your answers. Okay. So let's do some of these and see what we got. Now we're going to start off with tangent and cotangent because those are the harder of the three, okay? First off, tangent of negative square root of 3. That value has been reduced. So we have to be very, very careful here. Alright? I know that square root of 3 came from one of these two kind of points here. So we either have square root of 3 over 2, comma 1/2, or 1/2, comma square root of 3 over 2. And I also know that one of these values are negative. I don't know which one it is yet, but I know that one of them is negative, right? Tangent is y over x, so I'm going to get one of these scenarios here, 1 over 2 divided by square root of 3 over 2. And I'm also going to get square root of 3 over 2 over 1/2. Okay? The 2's reduce, right? And I'm left with 1 over square root of 3, which is square root of 3 over 3. And on this one, I'm left with just square root of 3. Why is this important to us? we need to know where this came from to be able to find it on the unit circle. Okay? Easy kind of thing that I remember. If it's square root of 3, and I'm looking at the numerator now, okay? If I end up with square root of 3, I had square root of 3 over 2 on top. If I end up with the fraction, square root of 3 over 3, okay, I'm going to be having the 1/2 fraction on top. So it's just something that you have to remember. Square root of 3 used to be like this. Square root of 3 over 3 used to be like this. It's something you have to memorize. Okay? So obviously if I'm given negative and tangent is in 1 and 4, I'm looking at the 4th quadrant, right? Okay? I have a negative square root of 3, so that means that my y value should be square root of 3 over 2, and my x value should be 1/2. Alright? The y values are negative in the 4th quadrant, right? So I'm looking at this right here. Okay, and then all I have to do is know what that angle is. Now remember, it's not 5 pi over 3. It's only these two quadrants. I can't go all the way around. So that's negative pi over 3. And I know tangent is actually a little confusing when you first see it. Okay, cotangent. Now, this one kind of put a star next to because a lot of people like to miss this. There's only 3 points that we can kind of get with tangent and cotangent, right? 3 different kind of style of points going around the unit circle. The first one is just like this, right? And it can flip places if we need it to. It just depends on where you are. There's also going to be 1, 0, and these two can switch places, right? Depending on where you are on the unit circle. And we're also going to have square root of 2 over 2 and square root of 2 over 2. Now, which one of these, knowing that this is a fraction, would actually make it equal 1 if I put them over each other? The answer is the only ones that are identical, right? Anything divided by itself is 1. Okay? These occur on the 45-degree angles. Alright? Well, let's kind of take a look at what we have. 1 is a positive value, so I know I'm in the first quadrant because all positive values are in the first quadrant for inverses. So I just go over there and I find square root of 2 over 2 on my unit circle, and my radian is pi over 4. And there's your answer. Alright. These are the ones that I'm going to kind of work with you, and then I'm going to give you a worksheet for the remainder of the class period. Okay? So, let's kind of throw this up here, just like this. Don't worry, I'll move it. I know most of you haven't written them all down. Okay? Secant is the flip of cosine. Okay? So I'm looking at the x values. X runs left and right, so this is going to be in the first or second quadrants. This value is negative, so that means I'm in the second quadrant, right? Okay, what did this value used to be for cosine? It used to be negative 1/2. These are things that we need to actually know. Alright, where did these values come from? What did they used to be? Okay, negative 1/2 is right there. So what angle am I at? 2 pi over 3. And there's my answer. Over here. Okay, here's that 1 again. It's a positive 1, so it had to come from a 45-degree angle. It's positive, so it's right here. So pi over 4. And all I have to do is find cosine of pi over 4 after that, which is just square root of 2 over 2. There's my answer. Okay, next two. Okay, here we go again. Secant's in the first and second quadrants, because it's the x value, just flipped, right? What was this value before it was flipped? It was 1/2. Okay, it's a positive value, so I'm in the first quadrant over here. Okay, the x value is right there, so I'm at pi/3. And then it just wants to know what sine of pi/3 is. So I just go over to pi/3, and sine is the y value. So it is square root of 3/2. Just like that. Alright. Let's do some cotangents. And I'm going to show you a little trick here, okay, with these composite functions with cotangents. So, first thing I need to do is find 5pi/3. And this is a regular function, so I can go all the way around the circle, right? So 5pi/3 is way down here. Cotangent is x over y. Okay? X over y. So that is 1/2 over square root of 3/2, just negative, right? Okay? Now notice what I'm not doing. I am not reducing this. I want it in its actual format so I know what is x and what is y whenever I'm finding these things. Okay? So by not reducing it, I know that 1/2 is x and square root of 3/2 is y. Inverse of cotangent is in the first and second quadrants. This is a negative value, so I have to be in the second quadrant. So I come over here and I look for it. There's x, there's y, one of them is negative, and that's what we need, right? So my angle is 2pi/3. Just like that. Okay, last two. And notice we are given non-unit circle values, so we're going to have to draw graphs for this. And remember, when we have to actually do the graphs and everything, the inverse is finding theta. And we don't need to know what theta is because our final answer wants a value, right? So just kind of keep that in mind. Okay, positive value, so I'm in the first quadrant. Okay, this is the flip of sine. So this would be opposite over hypotenuse kind of thing, just flipped over. So this is 2 and 5. Alright, so that is 5 squared minus 2 squared equals b squared. Okay, so 25 minus 4 equals square root of 21. I think we did that one yesterday, right? So square root of 21, not yesterday. The other day. Alright, so this is what I'm given. Remember that finds theta. So now I just need to find out what cosine of theta is. Cosine is adjacent over hypotenuse, so square root of 21 over 5. Alright. This is a negative value, so I'm not in the first quadrant with this inverse. Secant is the flip of cosine. Cosine runs left and right, so does secant. Okay, so I'm over here. Alright, so this is the flip of cosine. That means this is adjacent down here, and this is hypotenuse right there. Right? So this is going to be negative 12, which makes sense because my fraction is negative. And 13, remember the hypotenuse is always positive. Alright? Hypotenuse is always positive. Okay, so all we have to do is find out this side. If you remember, this is a triple. But if you did not know that, you could use the Pythagorean theorem. You should get 5 here. Okay, 12, 5, 13, well, it's 5, 12, 13. Okay? And again, the inverse is actually finding theta. Theta is actually this angle, if you want to get technical. Alright? So what is tangent? Tangent is opposite over adjacent. So tan of theta is -5 over 12. And there's our answer. Okay, so the remainder of the class, you guys are going to be working on a worksheet over these. Don't worry. These just take a little bit of time to process. The worksheet will be due tomorrow.